somewhere in here is a good value. Let's say I settle for that. Okay. 45. Significance of 45. What did we say yesterday? Area. Okay. But it's not as obvious if you just say 45. It's obvious that it relates to area. It's more obvious it relates to area if you include units with it. 45 centimeters squared. That's what helped it click for some folks that didn't see that on the way in. Okay. So make sure you're including a note with the constant and its associated units. So 45 centimeters squared or 7 inches squared, not just the number value. The units are almost as important as the number itself. All right. So there's a thing that we do when we get a curvy graph. It's called linearization, and it's not anything that I ever did in high school. And it's not anything that I really ever remember doing as a physics major. Cheers. But it is on the AP exam. And now that I know about it, it's kind of cool. Okay? We want to take this curvy graph and we want to turn it into this. Why do we want to turn it into this? Linear, so that's cool. It's not curved. That's cool. Okay? We get everybody's favorite like math equation. Y equals ax plus b or mx plus b. But we're gonna go with a in here because it's physics. So there we go. Why did they use m for the slope control? Why did they use m to represent the slope? I have the arrow. See, right? Cool. So we're gonna call it a. If I plot height versus width, I'm just gonna get a curve. I want a line. I should plot height versus. Run it by your neighbor real quick. See if they can kind of suss it out here. What should I plot down here? Okay, I'm hearing a suggestion for height and area. What would that look like?
It would be a straight line.
Because this would have a value of 45, right? It would just be a vertical line. So we're not going to plot height height versus area now. Height versus height, that'll work. So the clue is in what we have over here. Okay, because this is an inverse relationship, y equals a over x. X is width. Okay? I don't want to plot width here. I want to turn this into this. So I want to plot. What do I put in place of x so that I end up with this?
1 over x.
1 over x, aka 1 over width. So if I do that, now it's going to have that form, right? But it's going to be a linear graph. Well, let's check it out. Ooh! Now here's another important thing that goes along with this. Now on this axis I have 1 over width. A lot of people will try to say this. Nah, width is in centimeters. What is 1 over width then?
1 over centimeters.
1 over centimeters. Whatever you do to the variable, do the same thing to the unit. Ooh. Alright, so how do we make Desmos do this? Okay, like you could take that column and take the inverse of every x value and then plot it. But Desmos is computer-based. It'll do it for us. There's a way to do this in Pivot as well, and I'll show you that later. But in Desmos, if I want a graph of height versus 1 over width, I'm going to add an expression, open parentheses. I'm going to tell it to plot 1 over x1, comma, y1. You see it showed up here. Now, it just looks like a bunch of blue dots on the axes because now I don't need, it's doing, what do I want to say? It's doing 1 over the width down here. So those are small numbers. So I'm going to shut off this. I'm going to shut off this. With the Yave and Glaisa, I'm going to change the horizontal range to 3. 0 to 3, something like that. Wow, I didn't need that. Let's go 0 to 1. There we go. All right. Whoa. What's up with that? Okay, now I'm going to insert another expression. Y equals AX plus B. Oh, that's what I did. Let me do this differently. I wanted an aha moment that's not going to happen if I type it like that. AX plus B. Why is it only offering to add a slider for B?
Because we already have A's range.
I already have A down here, right? I said 45, but if you look at it, it doesn't quite match up. Maybe, let me try tweaking the B. Oh, it's trying to put a B of 1 right now. If I make B 0, that's not too bad. So same A value, same value for A. However, I swing this thing. Why? Because A represents the area, so it should still be 45 centimeters squared. So this is the linear version of the relationship between height and width. And often how that'll be stated on the exam, it won't be height and width. It'll be something else. But it'll say like, what variables would you graph in order to get the linear form of the relationship between gravitational force and distance, or something like that. Well, you have to look at the equation for your curvy graph, and then think about how you're going to modify this to incorporate it, right? So for my horizontal axis, if I want a line, I'm just going to take that and bring it on over with it. Okay? Weird. So we'll get some more practice with that. More practice with the short one. Your lab, if you haven't submitted it yet, actually, let me go into Canvas and show you what this looks like. So, required elements for what you're submitting. I'm just asking you to play around with this linearization stuff. I don't need you to do that. If you submitted it without it, you're fine. But you do need a note that mentions the constant A represents the area of 45 centimeters squared or whatever it is for you. You do need this thing. Height equals not 100 with the units. For me, it's 45 centimeters squared divided by width. All right. So that's all I needed there. And make sure you got your axes labels. Ooh, see now, for this graph, if I was submitting this graph, I'd have to go in and change this label. But I'm just going to shut that off, turn that back on, and I'm good to go. Boop. Cool. When you go to share, don't copy this URL. You got to click on the box by your name, and this is your share link. Otherwise, when I go in here, it just takes me to, let's see, who had it? So that works. This one? No, that's all good. I'm trying to find the one that didn't have it. Who did it? Oh, that's what happened. All sections. Boop. What's up?
Can I get the Spanish paragraph paper?
Yep, 1 second. Oh, no, never mind. Okay, never mind. Everybody did it right. So, smart group. We're cool. Dashboard. CMAC. All right, any further questions or concerns on the paragraphs lab? The Desmos.
So what do we need to write down?
I need a note that explains the significance of the constant. I need a note with the equation in the proper format, variables inserted in place of y and x. That's what I should show you. Okay, so hold the boat on submitting. Lab feedback and the AP Physics need to knows. So let me talk about how I grade labs and the purpose of labs. All right. Pre-COVID, grading lab activities. There's a lot of you. It's a lot of labs to try to turn around in a short period of time. So in order to be efficient, the system that I came up with for lab grades is this. Okay, I got 2 stamps. So your lab score is either like stamp 10 out of 10, cool, move on with your day. Okay? Or dislike stamp 5 out of 10, you got some revisions. That's how it works in science, right? You submit like a grant proposal, it doesn't get accepted, or you submit a journal article, it doesn't get accepted right away. You don't just like take the L on that thing. You revise it, you resubmit it, it gets accepted, now you're good to go. Okay, that's how it works in here. Dislike stamp 5 out of 10, comma, or now. Okay, there'll be feedback along with that. You make those revisions. Like let's say you submit it first, and you just leave the equation as y equals 45 over x. Boom, it's coming back to you with the dislike stamp. What is the Canvas version of a dislike stamp? Your score is a 5 out of 10. Okay, then look at the comments. So if it's a paper lab, it'll be a stamper, and on a paper lab, why this happened was I got tired of writing the same damn thing over again. I felt like Bart Simpson at the beginning of the show, where he has to like punish himself by writing the same thing over and over again. Why am I being punished because nobody puts labels on graphs these days? Okay, so instead I'll just write a number 1 on the paper lab, and that means you need labels on your graph and your graph sketch. More on that later. Okay, and things like units and major axes values. If it's got a definite vertical intercept, then that shows up on your graph. All right. If I write a number 2, it means your equation needs to be written with the variable names, the things, height and width, in place of x and y, because x and y are too generic. We want the specific equation for this relationship. Also, numbers need to include units where appropriate. Okay.
You need to use length instead of height.
If you use length instead of height, I'll know what you mean. If you use length and height, maybe I'll be confused, but is it length and height or length and width or length and width? I'll figure it out. That's good enough. Alright? But if you write y and x, it's coming back. Number 3, appropriate units on slopes and or constants. A lot of people just try to turn it in and say, oh, the slope is 45. 45 what? Okay, or like you didn't get it exactly like everybody else, you got like something between 23. Is that inches squared? Is that centimeters squared? Put the units on there so I know.
How do you put them?
How do you who?
How do you put the units?
In a note? So on Desmos, when you're trying to do it, you can't put it in the equation.
Yeah, I put them on like.
So you add a note.
For the axes, but
Yeah, you add a note and you just type the constant is 45 centimeters squared. That's 10 out of 10. That's 5 out of 10. All right. Back at the thing. Where's the thing? All right. So 3, appropriate. Da, 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 da. All right. When we're doing a linear graph, and when we're drawing it by hand, it's not going to maybe be quite as clean as you would like, because you're going to have your data points. Okay, data points to me, it's kind of what do I want to say? To represent it as a point is lying, because it's not a point. Okay, it really should have error bars on there. The true value of this lies somewhere between these bars. Okay, maybe even horizontal error bars. We're not going to get into that. You go a little farther down the road into physics and you can worry about that, or the biology or the whatever. But I just need you to understand that it's not really a point. It's more of like a schmear. Okay, this is a schmear, and that's a schmear, and there's a schmear, 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 schmear. So, by gosh, please don't connect the dots when you do this. I don't see that too much at West High, like the zigzag line. connect the dots is not the game we're playing. But then some people will still do it, but they'll only connect like 2 dots. They'll connect the origin and the last dot, or they'll connect the first dot and the last dot. What's so special about those dots? They're not special. You just gotta lay your ruler on here and throw a line down here. The goal of that line is that if you collect subsequent data, it's gonna fall kind of along the general trend of that line. Okay? So that's why I don't call it best fit, I just call it okay fit. So something like that. Try to not touch any dots while being as close as possible to all the dots. How about that for a weird rule, right? Okay? So then we throw the line on there. Once the line is on the paper, those dots don't exist anymore. Okay? So don't use them. This is the other great set that comes up, and this is number 5. You're going to get dinged with number 5 if you calculate the slope using, I should state this different. If you calculate the slope based on data points, you're going to get dinged with number 5, which tells you that the slope should be calculated using 2 indicated points on the trend line. Okay? Because what will happen, West Side kids will do this, they'll be like, oh, let's do first point, last point, and they'll just connect those dots. Still connect the dots. Don't do that. Okay? So once the trend line is down, now it represents all the data. So pick 2 points on the trend line that hopefully are the okay fit line. Try to pick ones that they go through like a corner on a crisscross on the graph paper. Calculate your slope based on that. Points on the trend line, not data points. That's a sin. That'll lose you points on the AP exams and in here. Okay? It's not going to have a huge effect on the value unless you got some of the weird outliers at the beginning or end of it, but science, damn it. Calculate your slope based on the trend line. Alright. So those are like the most common errors. Make sure you're not doing those. I mean, you're using Desmos, so you don't have to pick 2 points on the trend line. Desmos is doing a computery version of that for you. Okay, this is a paper graph or on the AP exam, plotting graph. Alright, what else do we have? Talked about submitting it. If you get it back and it's a 5 out of 10, fix it, get it back to me within the week, preferably. Okay? I don't want it at the end of the term. Maybe, do I need to say this? We should maybe say this because this was a whole poop show that me and Lalagos dealt with all summer with some kid, not from this school, okay? But grades were due at 8 a.m. on Friday before graduation for seniors. This kid trying to push his chips forward at 4 a.m. on that day without any heads up. I emailed him a couple weeks prior and said it had like 5 days to get stuff turned in. Boop, I submitted it, fixed my grade. No, that's not how it works, okay? So don't just let everything pile up and try to push it all in at the end, okay? Revisions for labs need to be handed in certainly by the end of the unit, hopefully within a week of when I return it to you, okay? Units are only 2 or 3 weeks long anyways, but it's a 5 out of 10. You can fix it, but do it in a reasonable timeline. Boop, boop. All right, what else we got here? Friends that were gone yesterday. AP Physics need to knows. There's a page that talks you about how to do Desmos for the paragraph lab, okay? AP Physics need to knows is a good place to go. So check that out. There's another thing I'm going to recommend the AP Physics need to knows for. And that's this page on linearizing a graph. And I'm going to come back around to that here in a second, okay? But anytime we graph data in here, and you don't straight away get something that fits with y equals ax plus b, you get one of these deals, or one of these deals, or one of these deals, or one of these deals. If you come to this page in the AP Physics Needs Notes, and you just click on that graph, it's going to tell you how to linearize that. Okay? So these are all just links. Right? I click on that. Linearizing a side opening parabola. I didn't monetize my videos. Why are there ads? Inverse square. That's how to linearize it. Okay? So this will be a commonly used resource What is this? I better fix this link. That's not a real link. So just know that that exists because you never know when you might need it today. All right. So on the calendar, this is our next lab that we're hopping into here. Okay. Joly photometer. And what we're checking out is the relationship, if any, between light intensity and distance. Okay? So if you look at how illuminated that purple thing is, as I move farther away, what happens to the light intensity of that thing? So is it getting more light now or less light? Less, right? Bigger distance, less light. What does that sound like? Very familiar, right? Okay. Make the distance smaller, light intensity increases. So we got that understanding coming into it. All right. What we're going to use here is a little device called a Joly photometer. That's a pretty happy sounding device.
I'm gonna assume that it's tricking us.
And so go down the page, hit the load the thing. And for you, it should just take you into the lab. So make sure that that happens, yo. So there are some things that are coming back in from last year that folks that have to do how to use big pivot is one. So you should all be able to just click on that and get into this. This is the first video on that assignment.
I don't think we. How do we?
Mr. Hardy?
Nope.
I don't think we can.
You're in the paragraph lab, right? I'll go back to the sentence. Oh, okay. Okay. Is it always been that? That's weird. Friday. What up?
Did we submit our literature ago for the inverse?
Mr. Hardy, how are we getting access to Joly?
Scroll down, bro. So click on the assignment for Friday, the pivot Joly photometer, and then when you get in there, just scroll down to the bottom, and that'll get you into the activity. Let me explain what that document is real quick. What I'm trying to do with this document is save you the heartache of getting a 5 out of 10 on your first pivot assignment. Last year, kind of like with writing on paper, not like to write the same thing over and over again, I was having to type the same thing in pivot. And so what I ended up doing was I put everything on a doc and then I just go copy and paste it off of there. Then I found a better way with Windows 10 and I got my copy and paste from Clipboard, much better. But anyways, here are all the common pieces of feedback that I had to give last year. So I'm putting this out on the front end, so maybe you can like peer review your own pivot before you submit it the first time. Okay? So anyway, you can come back to that after you're done with the lab. Here's the lab. Lab, boom, boom. There we go. So we got the sharp dressed individual, 2 blocks of wax. And then I don't understand why 2 pieces of foil. I think it's just some kind of like love of symmetry. Okay? So we're gonna make a little sandwich. Okay? So the 2 layers of foil are in between the wax blocks. And if you look at this, you can see how the, whatever you want to say, the illumination of the blocks changes with proximity to the light sources. And somewhere here in the middle, we find a spot where this block is equally illuminated as this block. In other words, the light intensity coming from this side is the same as the light intensity coming from that side. Fair enough? And yeah, it looks like it's pretty much right in between. So in other words, those lights are of roughly equal intensity. How do we turn this into something where we can get an understanding of how light intensity, so then there's some questions to answer, blah, blah, blah. How do we turn this into something where we can get the relationship for light intensity and distance then? Funny you should ask. So they got this video here, and you see block on the left, brighter, block on the left, brighter, pretty close to the, it's the same. And then in the end, block on the right, ever so slightly brighter. Okay? But look at the distance. It's way closer to that thing than it is to that thing. That's because there's only one mini bulb. Okay, this thing over here is just like a collection of little flashlight light bulbs. Only one of them is illuminated. You've got to get almost 70 centimeters away from the big bulb for the intensities to be the same. Okay, so this is kind of our control, if you will. This whatever watt light bulb over here. And at roughly 70 centimeters, the intensity is roughly equivalent to a 1 centimeter, or a one light bulb per ray. What's cool about pivot, if you didn't use it a whole lot, is we could change variables. I want to change the number of light bulbs. I'm going to change the number of light bulbs to 9. Well, what do you think? How is it going to have to get as far away?
Yeah.
It's going to have to go all the way over here? Nah. It's already pretty close right now, yeah? Maybe right about, right? Not as far. So at this distance from the light bulb, the light intensity matches that of a 9-volt source. Okay? What you're going to have is what relationship, if any, exists between light intensity as measured in light bulbs. I should correct this. Intensity measured in volts, number of volts. Distance measured in centimeters. How are we supposed to measure? You just got that thing that says 70. I wish this wasn't here. This screwed up so many people last year. That's for calibration purposes, but it really serves no purpose for you. If I come up here and I click on this, okay, see I click up here on the tools, it gives me a ruler that I can move around. Well, if I set the ruler right here, you see it just confirms, yep, 70 centimeters, all right. Where should I put the ruler, though, if I want to measure how far away I am from the big light bulb? Well, one suggestion might be the end of the light bulb. There we go. So that's where I'm putting my 0. And if I'm on, now you might need to double check when you change videos that the ruler doesn't shift, okay? But here I slide this thing way out. For my 44-year-old eyes, 57 centimeters looked like the correct spot to match the intensity of 1 bulb, okay? Now, question number 55, where should I measure to? What am I measuring to if I say 57? I'm measuring to the middle, okay? So distance, as established by us here, from the edge of the bulb to the midline of the wax blocks, okay?
Do we need to write all that in where it's distance line?
Who what?
Do we need to write all
Distance.
that in?
Yep. Truncated. All right. So that's the lab. Work together with your table buddy. If you don't got a table buddy, find a table buddy. Okay? If you're a singleton. And divide and conquer. There's 9 bulbs. You do the odds, I'll do the evens. Mr. Harding already did number 1, so we've got the same number each, right? So get your data. You should be able to follow it on the sheet. This is set due Sunday evening. So hopefully you get the data collection and you can get the analysis sorted out. You might get it sorted out in class yet. We're not out of here till 04. We'll see what happens. Yeah, it's due Sunday night, so we can talk about it in class Monday.
Does the variable value have anything to do?
What you got? Is it better with the lights on or off for this lab?
On.
Okay. What's up?
So, what's the variable?
I don't know. I don't know. Never figured that out much. What's up, boss?
So I practice right after school.
Okay.
I'm going to Wisconsin right after that because I have to move somebody in third one.
Okay.
So I was wondering if I could get the turn in yesterday's lab tomorrow instead of tonight because I won't really have
Oh, yeah,
a chance. Is that okay?
Yeah.
Okay, I'll have time to do it tomorrow.
Alright.
Thank you.
Try to turn it in.
Probably like the afternoon.
You want to work together. Do we need to measure all of them?
9 bulbs?
Yeah.
Yeah, divide and conquer. That's why I got lab partners. Find some.
Partners are for people who feel like they have to work for all of them.
Yeah. And then if you get it wrong.
What's up, Joe?
I'm still a little bit confused.
Here.
Like, yeah, of like, so are you saying like when you say on what we measure, you mean like these balls, right? Like the because you can change the number of balls we have.
Right.
So, what
So what are you? So based on that, what are you going to be changing? What are you going to vary?
number of bulbs are on the right side.
Yep.
Okay.
What is not changing?
The big bulb on the left.
Right.
Measuring the intensity, right?
Indirectly, we are, but like, what are you actually measuring on the screen?
Oh, the distance from the primary light bulb to the Joly monitor when it becomes equal.
That's important to state. So it's from that bulb to the position where both halves of the photometer are.
Oh, okay.
Same. Yep.
Thank
Cool.
you.
No, it's good.
So
What's up, sir?
do you think this is good?
So hit that cog. It kind of agrees with what we said, right? Like bigger distance, less intensity. Okay, and go include origin. All right, now. Oh, what did I say to plot? Do I not say?
I just did the intuitive thing and did distance on Y, small light bulb on X.
Yeah, I think we want intensity versus distance. Does it say?
Yeah, but I don't really know how we're gonna measure the intensity.
Hang loose, bud. All right. Where does it say? It's an easy fix.
We can measure the distance at which the large bulb has a brightness equal to, for example, 3 small bulbs. So I basically did
Brightness as a function of distance. So brightness on the vertical and distance on the bottom. Is that what you did?
I did small light bulbs on
Okay.
them because I don't really know how to find the brightness.
I should just say intensity here. I mean light intensity, which is measured in number of bulbs. So
I replaced the small light bulbs amount with.
so I think the unit is light bulbs, right? 1, 2, 3, 4, 5 light bulbs. The thing that's being measured in light bulbs is intensity. So I think your variable should be called light intensity or brightness. There we go. All right. So now click on that, change your axes. So we got brightness and then distance. All right. Now if we look at the graph. All right, cool. So this is where I would encourage you to go visit our friend
Desmos.
Well, not Desmos. AP Physics Need to Knows. Linearizing a graph page. When you compare those, what looks more like what you have there?
Inverse square.
Boom. So there's your recommendation for where to go next. So click on that, and it's going to tell you what to do.
Got it.
Oh my God. God damn it. Why? So dumb. So dumb. What is that all about? Freaking weird. Edit. There we go. All right, hey, this is kind of subtle, but what it's saying here is brightness as a function of distance is what we're trying to model here. Brightness or intensity. I'm kind of using those words interchangeably. So let me fix this. I'll call this brightness. That's the thing we're measuring. The unit of measuring is the number of bulbs. 1 bulb, 2 bulb, 3 bulb brightness. All right. Your graph should be a plot of brightness in number of bulbs. It'll do that part automatically. Versus distance, and that'll be centimeters most likely. Okay? So that's your raw graph. If it ends up as a curve, and by gosh, I seem to have been talking about curves a lot today, then you're going to go to the AP Physics need to knows. See if I can get there quickly. So if your graph is not a straight line, look for the thing that looks most like your graph. Here's a helpful hint. In the upper corner of the graph, there should be a little gear icon. And this should have been selected by default, but that's not how Pivot rolls. And I think what you need up there is include origin. Okay, just kind of like we talked about with Desmos the other day. We want to make sure that 0, 0 is shown on our graph. So hit the cog in the upper right corner, include origin. That'll make it a little more evident which type of curve you're dealing with. Yo. What's up? Whoa, yeah, okay, cool. Go to the label. And intensity, no uncertainty, that's cool. Hit done. Let's go down to the word model. It's you. Is there a ruler and a slap race? That might be the greatest. So it turns out both is actually yeah, that's like your intermittent measurement. 1 volt, 2 volt, 3 volt. So the variable I would call brightness. Up top. I don't even know what that does. Alright, now hold up. Go back up. Yeah, go back up. I said 1 volt was 7. Oh, you didn't include it. You hit the 3 dots there at 1. Does it let you like add and go above? Yeah, boom. Alright. Have a great weekend, everybody. Go West.
I was late today because I said I'm going to yeah, I'll try to come over.
Well, and then what happened? Like when we're on actual Friday schedule, does that make it worse? Probably. Because we'll start at 12:46. Oh, it's only a Friday. Yeah, it's Friday.
Only on Friday, yeah.
So we start at 12:46 and get done at 1:32. What time did you roll in today? I didn't notice.
Like 1:15-ish, 1:20.
Okay, so that'll be tough on Fridays, but we'll figure it out. We'll make it work.
But I'll try.
I appreciate the heads up.
Yeah, today I'll try to come. I'll try to come early, but